Now, the static keyword is basically a modifier that we use to associate a member with the type rather than an instance of the type. So in other words, if we use the static keyword, that means that you don't have to instantiate the class in order to access that static member. If I were therefore to create a static method, that means that without an instance of the class, I can access that method just simply by referring to the name of the class. A good example that we've already used is the POW method of the math class. You remember using the math.pow call in order to raise a base to a power, but we never once created an instance of the math class. It's not necessary. That's because the POW method is actually defined at the class level, not the instance level. So that means that every class really is divided into two logical segments. We have our static or class level members, and then we have the non-static or instance level members. So typically, every class then refers to or contains members, which may include methods, fields, properties, etc. And to use the instance members, you have to create an instance of the class. If you have a class that has both instance and static elements in that class, you cannot call any of the instance members directly from a static method. Now this sounds a little bit odd. If I have local methods, they're both part of the same class, why wouldn't I directly be able to call one from another? Well, it makes sense if you logically think about it. If you're dealing with instance members, we're assuming that those methods are running within an instance of the class. The static members are not. Therefore, since we have two logical segments, the static methods cannot directly call into the instance methods unless going through a defined instance of the class. Instance methods, however, are free to call static methods as needed. So every instance of the class has its own data, but there is only one copy of any static data.